Hi guys, this is Ms. Goki, and today we are working on Lesson 3, Linear Equations in Disguise. Our student outcome is students rewrite and solve equations that are not obviously linear equations using properties of equality. So let's look at the classwork. Some linear equations may not look like linear equations upon first glance. A simple example that you should recognize is x over 5 equals 6/12. What do you call this kind of problem, and how can we solve it? Well, first of all, you guys have seen this before, but this is called a proportion. And if you remember, there's two different ways to solve a proportion. We can, one, take and multiply each side by our 5. So we can multiply 5 on this side and 5 over here on this side. Or we can cross multiply. And we're going to cross multiply because that's easy to see where all our terms are coming from. So x times 12, we get 12x. Equals 6 times 5 is 30. So then we can simply just divide each side by 12. And we get x equals 2.5. So even though it didn't look like a linear equation, we cross-multiplied and got it to equal 12x equals 30. And that's a linear equation. We've seen that before, and we know how to solve it. So that's what this entire lesson is going to be on. So let's look at example 1. Given this linear equation that's in disguise, we're going to try to solve it. But in order to do so, we first must assume that the following equation is true for some number x. So in the last problem, we simply cross-multiplied, so we're going to do that again. We're just going to cross-multiply on each side, and we get 4 times x plus 1, x minus 1, equals 2, because we're cross-multiplying here, times x plus 1/3. Now, we've seen this. Since both sides have a linear expression, that means we have a linear equation and we can solve this. So let's distribute. We get 4x minus 4 equals 2x plus 2/3. Now we can bring our x's to one side and our constant numbers to the other side. So we'll get rid of the smallest number first, which is 2x. And we're left with 2x minus 4 equals 2/3. Now we can subtract, or add our 4, to both sides. And we get 2x equals 14/3. And then simply to get x by itself, we can just divide by 2, and we get x equals 7/3. So x equals 7/3 is our solution. Now looking at example 2. Can we solve this following equation? Well, at first I look at it and I'm like, I'm not sure that we know how to do this, but then I can remember, oh, yes, this is just a linear equation in disguise and we can cross multiply. So we can just do 3 times 1/5 minus x equals, and then we cross multiply on the other side and we get 7 times 2x plus 9. And now we have linear expressions on both sides, so we can simply just solve the equation. So when we distribute, we get 3/5 minus 3x equals 7 times 2, we get 14x plus 63. There we go. And if you couldn't see that this was a linear expression, you can definitely see that this is a linear expression here. So we don't have to continue solving it because we know we can solve this if it's a linear expression. So let's take a look at example number 3. Can this example be solved, or this equation be solved? Yeah, of course. We can just, once again, cross multiply. So if we do 8 times 6 plus x equals, we cross multiply on our other side, and we get 3 times 7x plus 2/3. Now we can go ahead and distribute, and we get 48 plus 8x equals 21x plus 2. And now we have x's on both sides and constants on both sides, so let's just bring them together. 8 is smaller, so we can simply just subtract 8x from both sides. and we are left with 48 on this side equals 13x plus 2. Now we can subtract our 2, and we get 46 equals 13x. Divide each side by 13, and we get x equals 46/13. Now, because this cannot be simplified anymore, we can simply just leave it as x equals 46/13. So as you can tell, this equation has one solution, and it's called a unique solution, if you remember from yesterday's lesson. So let's go ahead and move on to our next example, example 4. So can we solve this equation? Yeah. Once again, this is just a linear equation in disguise, but if we cross multiply, we can turn it into something we know how to solve. So 7 times 8 is 56. 1 times this whole term, 3x plus 9. You could have written it out like this, or you simply could have distributed it while you were doing it, because 1 times anything is always just itself. So this is also 56 equals 3x plus 9. We can subtract 9 from each side, and we are left with 47 equals 3x, divide by 3, and we get x equals 47 thirds. And once again, this is our unique solution because we only got one solution, and that's just to kind of reinforce what we learned yesterday. Now let's look at example 5. Example 5 is quite different than what we were looking at, and this is really kind of a linear equation in disguise. So example 5 says, in the diagram below, triangle ABC is similar to triangle A prime, B prime, and C prime. Using what we know about similar triangles, we can determine the value of x. So if you guys remember anything about similar triangles, this side right here, AB, is similar to this side, A prime, B prime. So we can write that simply by setting up a proportion, x over 2 over 9.5, because they're similar sides. And if those sides are similar, then they have to be equal to another set of similar sides. So we'll put our equal sign. So then we also have AC, which is x plus 2. And that side is similar to A prime, C prime, which is 12 centimeters. So now we have two different proportions set equal to each other. So how could we solve this? Well, if you guys remember from the previous ones, we can simply just cross multiply. And when we cross multiply, we get 12 times x minus 2 equals, and we cross multiply on this side, we get 9.5 times x plus 2. And then when we go ahead and distribute, we get 12x minus 24 equals 9.5x plus 19. Now we have x's in terms of their x's on both sides, and we have constants on both sides, so let's bring them together. We subtract 9.5x from both sides. These cancel out, and we're left with 19 on this side, on the right-hand side. On the left-hand side, 12x minus 9.5x, we get 2.5x. Then we bring back down our 24, our negative 24. And I'm just going to rewrite this equation right here up here so we have more space. So we have we have 2.5x minus 24 equals 19. Now we can add 24 to each side. And we are left with 2.5x on the left-hand side. And on the right-hand side, we get 43. And if we divide each side by 2.5, we get x equals 17.2. So if we want to find out the lengths of the sides, which they're not asking us to, we could simply just take our 17.2 and we can plug it back in for x.